Hey, it's Caleb. If you like this video, be sure to subscribe. Hey, I got a bunch of writing on the board, but don't look at it yet because I just want to talk to you guys for a minute. I just wrote it so you wouldn't have to watch me write like 50, 100 words, because that'd just be boring. So instead, I'm just going to talk instead. So much better, right? Anyways, last video and throughout the series we've talked about foreign keys. And as we know, they keep connections between tables in a database. So table 1, table 2, boom, foreign key. Connect from this foreign key references the primary key of this table over here. That's kind of how foreign keys work. They protect the integrity of our database. They keep everything consistent. Think about if there was no foreign key constraints, which keeps it updated and everything, then we would have to manually update all connections between tables. And that'd be a big waste of time, and it'd just be easier just to store everything in one giant table, which both solutions, either manually doing it or storing everything in one giant table, is not going to work. So we need foreign key constraints to protect the integrity of our database, right? It's called referential integrity. That's a big word, sorry. Alright, so now, this concept, these words, might be specific to a certain relational database management system. So these are from MySQL, but if you're using a different relational database management system, yours might be a little bit different. But in general, the concepts are pretty similar, so you're not wasting your time if you don't use MySQL, because you need to understand how foreign key constraints work. Alright, cool. So first of all, foreign key constraints, make sure that if you update the parent, the children are going to update, or cause an error or something like that. It's up to you. You can make the decision. And it's also going to prevent you from creating children when there's not a parent with that primary key. For example, if we have 5 users with the user's ID 2, 4, 6, 8, and 10, and then I make a comments table and I add a row that's like from the user 745, well, that person doesn't even exist, so that's not going to work. So that's why foreign key constraints are important, because they, once again, protect our database and make it pretty much self-managed rather than us having to manually update everything. So let's begin. Alright, let me get a piece of chalk. This one looks nice. I'm getting pretty low. This is the biggest piece of chalk I have left. Alright, so when we create an SQL statement, we can add these two keyword phrases here, on delete and on update. This refers to the foreign key constraint. So but it's talking about the parent. So when we update the parent, we want get away, you stupid fly. Alright. When we update the parent, we want the children to do something. When we delete the parent, we want the children to do something. That is what these keywords mean. So these keywords, it's talking about the foreign key constraint, and it refers to the parent. Alright, so let's just draw some basic tables just to kind of keep things. I'm not going to give any specific examples yet. I'll just kind of draw things out. So let's say we have a parent here. And as you learned in previous videos, the parent is the primary key, right? And then let's reference this primary key with a child. Okay, let's not draw this line yet. And then we have a foreign key. This primary key is a column within the parent, and every single row has a unique value. The foreign key is a column within the parent, and it references the primary key. So the value 400 in a row could reference the value 400 in this row, in a row of this table. You get it. I've explained it enough. Now let's just make another child table. So these are both foreign keys that reference the same primary key, but they're two separate tables. So yeah, like we could have a user table, and then we could have a comments table and an orders table, for example. They both are bought or commented by a user. So these foreign keys reference primary keys. So every single value within the table of the children, within the foreign key column, needs to be a value that is present in the parent column. Now, these values right here, these options, refer to the parent. So when we delete the parent or when we update the parent, we want the same thing to happen to the child or whatever the options are, and we'll talk about the options in a second. So that's kind of how these work. Now just to kind of clear things up, I'm going to erase these words here just because it's getting a little crowded, you know. I want it to be peaceful. Alright. Okay, so this is kind of how it's working. Foreign keys point back to the primary key. These options refer to what happens to the parent. Now these options right here, these refer to what happens to the child. Okay, now it's getting real confusing. There's arrows everywhere and like graphs and diagrams and whew, but you'll get it, don't worry. Restrict, you might also hear as no action, is, well, at least for MySQL, in different database management systems, these might be different. But anyways, restrict is going to throw an error. So if we try to, like, we can give one of these for each option. So on delete, we could either give restrict, cascade, or set null, or null. On delete, we could have it restrict, cascade, or set null, just to add more errors, you know. But let's say we're working with delete right now, and we want to use restrict. So within our SQL statement, we could say on delete restrict. So on delete restrict, and that is going to give us an error whenever the parent is deleted. So if I tried to delete the user with the ID, I don't know why I'm writing all that out. Let's just say the ID of 504, and then this child has a row that has 504 within the foreign key column, well then it's going to throw an error and it's not going to happen, and the parent will not be deleted. Not going to happen. So that's how cascade on delete works. I'm sorry, restrict on delete. Now restrict on update, if we updated that parent and changed their primary key, so let's say we changed 504, and these children both reference 504 with the foreign key, and then we change this to 508, and it's not going to work, and it will go back to what it was originally. Because we have it restrict. We're not going to let that happen, you see? Alright, what about the next option? Cascade. Cascade will do whatever we do to the parent to the child. Let me clear this up a bit. This is confusing me. Alright. Just smearing chalk all around, you know? Totally helping. Alright, so now if we cascade on delete, that means if we delete the parent, we're going to delete the child as well. So we delete 504, and boom, children are deleted, boom, child deleted. So now 504 doesn't exist at all. So like for example, if this was a comments table, and we had a comment from the user with the user ID of 752, and we deleted 752, the user, well then obviously all of his comments by him should be deleted too, because we'd have a comment by a user that doesn't exist, which isn't supposed to happen. So cascade on delete would do that. On update is if for some reason we updated the primary key, which obviously shouldn't happen because primary key should be never changing, but you still want that protection on your database. On update, if we have cascade, if we change like 504, let's say these people exist again. I'm just going to erase this because I don't, oh yeah, okay. So these people exist again, 504, 504. These references 504. And if we update this to 508, well that means all of the children will update as well. So now it connects within different tables. Finally, we have set null. And what that'll do is it will basically just set the children as null for that specific value. So if we deleted the parent, this is just going to get rid of the value. The row should still exist, but the actual foreign key reference, it no longer references anything. It's empty, so it's not referencing anything. So the column for that row, so like let's say we have a comment and it's a comment from Billy Bob with the ID of 504, if we delete that, we're going to have a comment with no poster or no commenter at all. It's just no value. That's what set null will do if we use on delete. On update, same thing. If we change the ID of the parent, change it from 504 to 508, well, all of the children are going to be set to no value as well. Alright, now there's one important thing with set null. The children have to have, they can't have, I should say, the not null characteristic. We talked about that in previous videos. I'm just going to put NN for short. If this is not null, and we update, if we have on update set null, and we update 504 to 508, can you even, have I been cutting this off this whole time? Alright, we set 504 to 508, I think you can see that one. Yeah, you can. If we change 504 to 508, and this is not null, it's going to be like, we can't do it because we can't set it to null, because it has the not null characteristic, which means every single row has to have a value for that attribute or that column. So it'll give an error and it'll go back to how it was. So that's an introduction to foreign key constraints. Sorry if I talk fast. But yeah, cool stuff. It's important stuff, so learn it, study it, and learn it for your specific relational database management system. Obviously, I'm trying to keep this series pretty broad, so any relational database can benefit, any relational databaser, if that's even a word, can benefit from it. Alright, so see you guys in the next video. Be sure to subscribe.